G'day guys, how's it going? So in this video, we're going to start looking at string slices in Rust. So what is a string slice and how does it compare to a regular slice? Well, obviously a string slice works with a piece of text only. And when I say a piece of text, I'm not necessarily referring to strings. A string is its own type and it also works with text, but a slice does a little bit more in regards to how it's stored, right? And I'll get to that a little bit later in a future video. But just understand that a slice is basically a series of characters, right? So it can either be a sub list of characters from a string, or it can be what we'll see in a minute, a literal piece of text in our code. So what I mean by that is if I do simple slice like this, and I type this is a simple slice as a literal string, this is considered a string slice, right? It's not a string like you would know in other programming languages. Other programming languages would call this a string. In Rust, we call this a string slice. All right, so that's the distinction. A string is literally when you go, let a string equals, and then you got to use like one of the string methods to either create it or get it from a what we see now as a string slice. See how the value there is a piece of text? So that's what we've been passing in all this time, right? Is a string slice, and we didn't know it, or I didn't mention it. Now I can, right? So that's what I mean. So a piece of text is what is considered a string slice. But it can also be derived from a string. Okay, so let's show an example of that. So if I go let some string equals string from, and there's our slice, and we'll say hello, oops, spell it right, world. So there's our slice. We can then take a slice from this string. So we can use our range operators, right? Like we've seen in the past. So we go let hello slice equal to some string, and we can use our range operators to do that like we could with other slices. And then I'll just do the same for, let's grab the word world. So we'll go from 6 to the very end. Let's go world like that. And we can print these out just to prove it works. So hello slice. World slice. And what's going on here? Sorry, my apologies. I need to get a slice from a string, you must refer to the string using reference. You can't use the object, because if I use the object, then I'm doing a copy. Sorry, not a copy. I'm doing a ownership change, and I don't want to do that. So we have to use references. So now I go run, and we can see hello and world. Cool. So we've derived a string from a slice, string slice. We've then created two individual string slices from that string object that we just created. Cool. So just think, slices are just pieces of text, and it can come from a variety of different locations, whether it be a literal like this, or from some kind of operation that returns a piece of text, which the range operator on a string returns a piece of text. Now the type is referred to as @str, so it's a reference to str object. And that's what you'll always see, but it's usually inferred anyway. You don't have to worry too much about it. But just know that this is the type you need to work with if you want to say define a parameter in a function for that. And we'll see that in a minute. Cool. So that's a simple example of creating slices from strings. So what can a string slice do when it's derived from a string or a piece of text? Well, generally they're read-only, right? For the most part. Like, so for example, a slice will not contain, even if I make it mutable, right? Which I'm not going to bother. But if I try to call .insert, that doesn't exist. All right. but it does have methods that are similar to what we've seen on the string. So there is a length, for example, on a slice. There's, let's say, we can get as bytes, right? So all the read-only operations that you would think that you've seen on a string, generally they're here on a string slice as well. But the ones that aren't are ones where we manipulate it, right? So remove and things like that. Now, I haven't spoken about these other functions yet on the string because I wanted to get through slices first. But there are things like to, lowercase, and stuff like this, but they return a string. See how it returns a string there? So if I was to go let lowercase string equal word slash to lower, if I was able to print this out, and I'm going a little ahead of myself here, but that's okay. So this function is available for some string and for world slice. So if I run this, you'll see the lowercase w there. But if I was to change this to some string, that also has the same method. And it does it for the whole thing, right? So this allows us to do, lowercase on a portion of that string rather than the entire string. Cool. So they're the type of things that you can do. Now, the only real use case I've seen for mutating a slice is if you want to change what it points to, which I'll show you an example of that now. So if I decide that we'll just remove most of this and we'll just make this mutable, all right? The only thing you can really do that's of any value, if you wanted to do this, is to point to something else, like another piece of text. All right, you can go print line, hello, slice. And the compiler won't complain. Well, actually, it says it was never read. Oh, yeah, sorry. This is complaining because it generally wants you to read it before you mutate it, right? It's just a warning. But there you go. So it reads it out before it's changed, and then you change it, and then it reads it again. So the warning before was saying, well, why bother doing this if you can just set it to high up here, right? That's what it was complaining about. But as soon as I print it out, it then goes, oh, okay, I see you wanted to print it out. Then you want to change it, then you want to print it out again. Cool. All right, so that's basically most on slices. I'm trying to think of what else is there. Yeah, so we showed that they're read-only. Now, in regards to functions, right? This is probably the last thing I want to talk about. In regards to functions, say we wanted to deal with printing out text or just reading from a piece of text in our code, right? What you will generally do is you won't do the following, right? So which show not to do first. So say I create a function and I go print string, and the parameter to it is what we've seen in the past, a reference to a string, like so. And then inside here, we'll go print line, and just for the fun of it, we'll just print a string, all right, like this. Now, I'm just going to change this code to make this immutable again and to get rid of the two print statements. Now, if I call print string from above, right, and I pass in some string, sorry, a reference to some string, like so, and I'm just going to comment out the slice for a second. If I now save this and run it, it's going to print the string out just fine, right? Because the parameter is a type of string, right? But what I can't do is I can't do the following, right? I can't take the same thing and use the slice. Now, at the end of the day, slice is also just a piece of text, similar to a string, right? But when I save this, it's going to complain and say, well, the arguments aren't correct, right? I'm trying to pass in, well, first I don't need that secondary reference because it's inferred here. So let's deal with that issue. But saying here, it's saying I need an at string and not an at str. Cool? So as a result of that, I can't call this print string method to print out the slice. Now, wouldn't it be nice if we could print out both strings and slices, depending on what we're dealing with in our code, right? Well, that is when we can basically create a similar type style function, but instead of using a string this time, we can use slices. So now we pass in an str, right? And I can go print line a slice, like so. And I can call print slice down here and save, and now everything will work, right? Cool, so the slice is now printed out. But here's the thing, I had to create two functions to deal with both strings and slices. Well, wouldn't it be great if we could use one? The answer is we can. What we can do is, instead of using print string, a string is essentially a slice, right? It's just the full length, right? So the string is a full length slice. So as a result of that, I can now pass a reference to the string as print slice, and that will infer that full string as a string slice. And that will actually compile and run and work as well. All right, so that's the beautiful thing about strings and slices, is that if I ever need to just read information, I can use the type of slice and also pass in a full string. Cool? Now, in terms of writing, like I said, there's really no benefit to mutating a slice. So you'll stick with the traditional approach of saying something like this, right? Update string, and you'll go a string, and it's a type of @mute string, right? So this is no different than before. And say I want to go a string dot push, and we'll add in another exclamation mark, right? So in this situation, we still need to use the string type as a mutable, right? So then I can come down here. I can update that string, passing in @some string, but I can still call print slice, like so. And what's going on here? Oh, sorry, this should be @mute some string, silly me. It's still complaining. Because I didn't set it to mutable. That's the one thing about Rust you'll realize over time, is that sometimes you forget to include mute in places. So now I'm mutating that string, and now I can print it, even though I'm printing it using that slice function, right? This will still work just fine. Cool? So that's all I want to show in this video. In the next video, we'll look at some more methods to do with strings and slices, and then we'll look into basically how literals are stored in Rust. So I'll see you all then.